Okay, welcome to the 2001 pre-AMC 8 SaMi video. I'm Olivia, and let's get started. So, we have Casey's shop class making a golf trophy. So he has to paint 300 dimples, and it takes him 2 seconds to paint one dimple. So, how many seconds is it going to take him to paint all of the dimples? So it's 300, and it takes 2 per dimple. That's 300 times 2. That's 600 seconds. Okay, so how many minutes are in 600 seconds? That'd be 600 divided by 60, right? Because there's 60 seconds in a minute, gives us 10 for our answer. All right, moving on. We've got two whole numbers that add up to 11 and their product is 24. So what two numbers have product 24? Well, let's list them out. We've got 1 times 24, 2 times 12, 4 times 6, and 3 times 8. Let's pretend I did it in a different order. Okay, and which of these adds up to 11? Well, 1 and 24 doesn't, right? That's too big. And so is 2 and 12. 4 and 6 adds up to 10, which leaves 3 and 8, right? 3 plus 8 is 11. So those are our two numbers. And which one's the bigger of those two numbers? That would be 8, which is our answer. All right. Moving on. Okay, Granny Smith has $63. She has $63. Alberta has 2 more than Anjou. So Alberta equals how much Anjou has plus 2, right? She has 2 more. And then Anjou has 1/3 as much as Granny Smith. So 3 times the amount that Anjou has would equal the amount that Granny Smith has. Okay, so how much money does Alberta have? We can use our first equation and plug it into our third equation to figure out how much Anjou has, and then use how much Anjou has to find out how much Alberta has, right? So if Granny Smith has 63, we know that 63, which is Granny Smith, equals 3 times Alberta or 3 times Anjou by our third equation. So dividing both sides by 3, we've got 21 equals A. Anjou has $21. Okay, and then using our second equation, E equals A plus 2. So we have E equals A plus 2, and A is 21. E equals 21 plus 2, that's E, which is 23. Okay, so we want to use these 5 digits to make the smallest even 5-digit number that we can. All right, so here's our 5 place values, and it needs to be even, right? So that means either 2 or 4 have to go in the ones place. And we want it to be small, right? So we're going to put our smaller numbers in the higher place values, right? Because if we have a 1 in front, that'd be smaller than any number with a 9 in front. Okay, so we'll start with a 1. What's our next smallest number? Well, we can use 2, right? That just means we have to use 4 as our ones place digit, which is smaller, right? If we switch those two, if we went 1, 4, that'd be a bigger number than 1, 2. Okay, keep going, 3, and then since we already have 4 set, the only number left is 9, and it's asking for the tens place digit. That would be where our 9 is. Okay. Ooh, it's a dark and stormy night. So, flash of lightning, and then 10 seconds later, he heard the thunder. So, speed of sound is 1,088 feet, and it took him 10 seconds to hear it. So, it traveled that much times 10. So, we need to estimate to the nearest half mile how far Snoopy was from the flash of lightning. Okay. So, using miles, we can have 10,880, divide that by 5,280, and doing this, you're going to have to bash it, do it out by hand. Take your time with that, but when you get the answer, come back, and it is 2. Alright, we've got 6 equally spaced trees. The first to the fourth is 60 feet. So we've got tree 1, 2, 3, 4, 5, 6. This distance here, that's 60. And we want to know the distance in feet between the first and the last tree. So we need to go, so how much space is between each tree? So from 1 to 2, how much distance is that? Well, we know between 3 trees, right? 1 to 2, 2 to 3, 3 to 4, that's 3 distances. That's 60 feet. So one distance is going to be that 60 divided by 3, right? So 60 divided by 3 is 20. So all of those distances are 20. You add them together and you get 60. All right, so between the first and the last tree, we've got another 2 distances, another 2 20s. So we've got 5 times 20, that's 100. That's our final answer for the distance. Okay, Kite Olympics. All right, we want to find our area of the small grid. So we know that this distance here is 1, right? So we want to find the total of all of the area of the kite. And something helpful is that if you notice, we can break this into pieces, right? And the left half, right, everything on this side, is going to have the same amount of area as everything on the right side. So that's helpful. We only need to do half of the kite. So let's do our top triangle. That has height 2, width 3, and then our bottom one, width 3, and height 5. So that top triangle has area 2 times 3 divided by 2. That's 3. And our bottom one has area 3 times 5 divided by 2. That's 15 over 2. And remember, the left side has the same area as the right side. So we need to multiply them both by 2. So we've got 6 for the top part, the top 2 triangles, and 15 for the bottom 2 triangles, which is a total area of 21. Okay. Now we want to find, so she puts bracing connecting opposite corners of the kite. So that's going to look like this, right? But she does that for her large kite, which we know is triple the height and the width of our thing. So this small kite, that has height 7 and width 6. Okay, so triple that is going to be 21 and 18. So how many inches of bracing material? Well, she's going to need the 21 plus the 18. That makes 39. Answer choice E. And lastly, her large kite is covered in gold foil, which is so fancy. And it's cut from a rectangular piece that just covers the entire grid. How many square inches of waste material are cut off from the 4 corners? Well, we know from our previous problem that the large one is a 21 by 18, right? And Genevieve, the area of her large kite that has 21 by 18, that one's going to be, well, instead of a height of 2, right, that her small kite has, it's tripled. So we've got 6 by 3 times 6, which is, 3 times 3, which is 9. And then here has a height of 5 times 3, which is 15. And another width of 9. So we've got 15 times 9 plus 6 times 9. That's a little bit confusing to look at, but let's do 15 times 9 is 45. 9, 135, plus 6 times 9, which is 54. So those two together have area 189. So that's the area of her large kite, minus the area of the entire gold foil. So that's 21 times 18, which we can do. So that's 18 and 36. So the entire area is 378 minus the 189 gives 189. Or another way you could look at it is you could break it down, seeing like this triangle is the same as this triangle. So instead what we could do is we could have that triangle and stack it on top, right, to take up this area. And same with this other triangle, you could move it over here. So visually it does take up half the grid. So Collectors offering to buy state quarters for 2,000% of their face value. So how much is a quarter worth? Don't forget, a quarter is 25 cents or $0.25. Okay, at that rate, how much will Brighton get for his 4 state quarters? Okay, so if 100% is 25 cents, how much is 2,000%? So we need to multiply by 20 to get to 2,000%, right? So 100 times 20, that's going to equal the 2,000. So 25 cents times 20, that is $5, right? Okay, and he has 4 of them. 5 times 4 makes $20. Okay, we've got points with coordinates. So A is at 3, 2, 1, 2, 3, 1, 2, that's A. B is at 3, negative 2. C is at negative 3, negative 2. We'll pretend that's some point. And D is at negative 3, 0. So we want to find the area of that quadrilateral. Okay, so what we can do is we can break it down into different shapes. So I can have this rectangle part and then this triangle part. So let's do that. So our rectangle on the bottom, that has length 2 and width 6. And then our triangle has base 6 and height 2. Okay, our rectangle's area 2 times 6 is 12. Our triangle has area base times height, 6 times 2 divided by 2, which is 6, right? 6 times 2 is 12 divided by 2 is 6. Adding those together, we get 18 as the area of quadrilateral ABCD. All right, now we've got some simple stuff. So we've got A symbol B. So that's the same as A plus B over A minus B. So 6 symbol 4, where 6 is like A, 4 is like B. Right, so we've got 6 plus 4 over 6 minus 4. So that turns into 10 over 2, which is 5. So now we have 5 symbol 3, where 5 is like A and 3 is like B. So 5 plus 3 over 5 minus 3, which is 8 over 2. That is 4 as our answer. Okay, Rochelle's class. 12 prefer chocolate, so 12 for chocolate, 8 for apple, 6 for blueberry, and as many of the remaining students prefer cherry as lemon. So chocolate, and we'll just say, I'll just draw it out. That's a cherry, and that's chocolate. Chocolate equals lemon, or cherry equals lemon. Okay, for Rochelle's pie graph, showing this data, how many degrees should she use for cherry pie? Okay, so let's figure out how many students like cherry and lemon. So there's 36 total. We've got 12 like chocolate, 8 like apple, and 6 like blueberry. So those 3 total categories add up to 26, right? So 26 out of the 36 don't prefer cherry or lemon. And so 10 are left that do like those 2. And the same like both, so it's 5 equals 5, and then together makes 10. 5 like cherry, 5 like lemon. So how many degrees should she use for cherry pie? So we need 5 out of 36. And a circle is 360 degrees, right? So we can, if we're dividing 360 by 36, so each segment is 10 degrees, right? And for the cherry, we need 5 of those 10 degrees. 5 times 10 makes 50 segments total, yeah. So Tyler, 3 choices of meat, 4 choices of dessert. But here's the vegetable is tricky, right? Because he's choosing 2 different kinds. So the first vegetable he chooses, there's 4 different options, right? Baked beans, corn, potatoes, or tomatoes. That's 4 options. But for the second vegetable, now he's already picked one. Let's say he picked beans. Now there's only 3 choices left for what vegetables he could pick, either corn, potatoes, or tomatoes. Tomatoes are not a vegetable, we'll count it. So there's 3 choices for the meat, 4 choices for the dessert, 4 choices for the first choice of vegetable, and then after he's chosen one vegetable, there's 3 other vegetables to choose from. So that's a total of 144 different combinations. 144 combinations. Don't forget that either if you choose baked beans and then corn, it's the same as choosing corn and then baked beans, right? Order doesn't matter. So, right, let's say you chose beans and then corn, that's the same as corn and then beans, so we've double counted, right? There's 2 times the amount of cases that we need. We need to divide that by 2, and we get 72 as our answer. Okay. We got Homer peeling 44 potatoes at 3 potatoes per minute. 4 minutes later, Christian joins him. So after 4 minutes, Homer has peeled 12 potatoes. Okay. And Christian peels at a rate of 5 potatoes per minute. When they had finished, how many potatoes had Christian peeled? So once Christian and Homer are working together, they're peeling 8 potatoes per minute. So out of the 44, Homer already peeled 12 at that point, so that's 32 potatoes left. They're peeling 8 potatoes per minute, so it's taking them 4 minutes once Christian joins, right? And if he's peeling 5 potatoes per minute for 4 minutes, we have 5 times 4, that's 20 potatoes that Christian peels. Okay, 4 inches on the side, folded in half vertically. This is a 4, and then it's folded in half, so this is a 2. So both layers are cut in half parallel to the fold. Right, so this is at 1 and 1. So that's giving us 3 rectangles, 2 small ones and 1 large one. So notice that the small rectangle, that's going to be on the end, right? So that's the 4 by 1 that we're talking about. The large rectangle in the middle has a fold, right? So this actually continues on another 1. So our large rectangle is a 4 by 2. So the perimeter of the large rectangle is 4 plus 2 plus 4 plus 2, which is 12. And the perimeter of the small rectangle is 10, right? What's the ratio of the perimeter of one of the small to the large? 10 over 12, that is equal to 5 over 6. All right, who wants to be a millionaire? So we want to know between which 2 questions is the percent increase the smallest. So from 1 to 2, the question increases by 100%, right? To get from 100 to 200, you increase it by 100% of 100, which is 100. This is a 100% increase. All right, 2 to 3. That increases by 50%, right? Increasing by 100, and 100 over 200 is 50%, right? So that's a 50% increase. Okay, from 3 to 4, we've got 66% increase, right? Because it's increasing by 200, 200 over 300, that's 2/3, that's 66% increase. From 11 to 12, we've got just under a 100% increase, right? Because 64 times 2 would be 128, so we're just short of that. So we've got less than 100%, but not too far off. And then from 14 to 15, that's a 100% increase. So what's our smallest here? That would be from 2 to 3, which is only 50%. Okay, what's the probability that the product of 2 dice being rolled is a multiple of 5? The only way that the product is a multiple of 5 is if at least one of those numbers is a 5, right? So we can either have 5 for the first dice and then 1 through 6 for the second dice, or 1, 2, 3, 4, or 6 for the first dice and 5 for the second dice. All right, because we already have the case where the first dice is 5. So there's a 1 in 6 chance of the first dice being 5, and then a 1 in 1 chance of the other dice having any number, right? Because it doesn't matter what the second dice is, so that's a 1 in 6. And in the other case, there's a 5 in 6 that the first dice isn't a 5, times a 1 in 6 that it is a 5 for the second dice, which is 5/36. 5/36 plus 1 over 6, that's 11/36. Okay. Car M travels at a constant speed. That's the dashed line, and car N is twice the speed for the same distance. So N's speed has to be higher than M, right? Because if N is going twice the speed, that's eliminating C and E. So it's also going for the same distance. So if car N is going faster, it's going to take it less time to go the same amount of distance, right? So B is out. And then because we're going twice as fast, that distance is going to be cut in half, right? So N is only slightly faster than M, but in D it shows N is twice as fast as M. So that's our answer. So Kalina shows people her scores, and then Quay says, 2 of us have the same score. So he doesn't know anybody else's score besides Kalina's. So that means he must have the same score as Kalina. So we'll have Q equals Kalina. And then Marty says, I didn't get the lowest score, which means Marty must have gotten more than Kalina, right? Otherwise he'd say, maybe I do have the lowest score. So that means Marty has more than Kalina. And Shauna adds, I didn't get the highest score. So that means she didn't get as much as Kalina, right? Otherwise she said, I could have gotten the highest score. So Kalina has more than Shauna. So Marty has more than Kalina, and Quay has the same as Kalina. So Marty also has more than Quay. And then Shauna has less than Kalina, and so that means she must also have less than Quay. So from lowest to highest, that'd be Shauna is lowest, then Q, then M. Cool, good job.